Okay, so the end of question number 7, you should have ended up with 12.89 kilograms. That only leaves us question number 8 from your homework last night. Now 8 might look weird and funky because of the fact that there's two sloping surfaces, but it's not really any big deal. Just treat them as two inclines back to back. So on this side, you have FGA, and so acting down the incline will be FGAX. And on the other side, FGB acting down the incline will be FGBX. And if you read the question, it says it's frictionless, so I've made it actually really easy for you. And the first part of the question says, which way will the system move? Well, if we draw the system in a straight line, here's A and here's B. If there's no friction, then the only thing pulling this way will be FGBX. And the only thing pulling backward will be FGAX. Which way will the system move? Well, that'll be determined by which one's bigger, FGAX or FGBX. So to answer the first part, you should actually find the value of FGAX, and it's just going to be MAG sine theta. So it's going to be 100 kilograms, 9.81 meters per second squared, and the sine of 30. So FGAX is going to be 490.5, I believe, right? Half of that is 4.905, move the decimal, yeah. Okay, and then, so that's FGAX. Now find FGBX. It's going to be MBG sine theta as well. So it's going to be 50 kilograms times 9.81 meters per second squared times the sine of 53.13. So that's 0.8. 0.8 times 50 is 40. 40 times 9.81 meters per second squared, 392.4. So 392.4 newtons. Which one wins? A. Okay, so the system's going to move this away. Okay, so that's the first part. Second part, what would the acceleration of them be? So now do sum of the forces. Sum of the forces is equal to M total A. It'll be FGAX minus FGBX equal to MA plus MB divided by A. So A will just equal, so we had 490.5 newtons minus the 392.4 newtons, and on the bottom 100 kilograms plus 50 kilograms. Okay, so do the math and get 0.654 perhaps? 0.654 kilograms. No, not kilograms, it's an A. Meters per second squared. And in part C, what is the tension? So you have to pick one or the other. They're both on an incline. It doesn't really matter which one. I might pick A just because it's 100 easier numbers. So FT this way, FGAX this way. Sorry, usually I have this sitting on something so it's not moving. It's probably been moving all over the place and I haven't noticed. So if we do sum of the forces is equal to MAA, it'll be FGAX minus tension is equal to MAA. Take this over, so FGAX minus MAA will equal tension. So that was 490.5 newtons minus 100 kilograms times 0.654 meters per second squared, so 65.4. And so when you subtract them, you get, did I do that right? Oh, did I screw up again? So according to this, you should get, oh yeah, it's going to work, 425. I just can't subtract well in my head this morning, I guess. 425.1? 425. Yeah, I think it's going to be 0.1, maybe, newtons. Okay? So there are all your homework questions. So what I would like you to do now, I'm going to give you 3 questions for homework. One is the one on the sheet, and the other 2 are 2 I'm going to draw for you. Okay? So just 3 questions. Please try these. So the first one is, they're both going to be inclined planes. Okay? So draw an inclined plane. And it's going to kind of be like the one I gave you yesterday. I'm going to put a box here. Going to hang another one up over the top of the incline. MA, MB. So I'm going to tell you that the mass of the guy hanging off the bottom, or do we call it, you can call it 1 and 2, whatever, but this guy hanging off the side, this one here, is 18 kilograms. Okay, the acceleration of the system is 3.946 meters per second squared. The coefficient is 0.2. Let's make this angle 30 degrees. It's going to move up the incline, and M2 or MB is going to move down. And I'd like you to find what's the first mass. What's the mass of the box on the incline? Okay? For the second one that I'd like you to do, example 2. I don't know if it should be problem 2. I guess it's not an example if I'm not doing it for you. Example 2. This time I'm going to put 1 on the incline here, but I'm going to hang 1 off the lower end. Okay, so I'm going to hang 1 down here instead. So we'll call this one M1. We'll call this one M2. M1 is going to be 80 kilograms. The acceleration is going to be 2.065 meters per second squared. The angle this time is 20 degrees. And the coefficient this time is 0.35. And I would like you to find M2. Find the mass of the dude hanging down. Okay? So those 2, and then this one. Okay? And it asks you for a range of values. So let me just explain number 9 for a minute. I actually have 2 minutes before, or maybe I do only have 1 minute before it runs out. Okay? So we have a system like this, but it's at rest. And I tell you 2 of the masses, but not the third one. So I don't tell you mass number 3 here. If mass number 3 is really big, the system will move this way. So I want you to find what is the mass that'll make the system move this way. In other words, assume that friction is acting down the incline. Okay? But then I could make mass 3 really tiny. And if I make mass 3 really tiny, then the system will move up and down the incline, which would mean friction would move this way. So I'd like you to find the 2 possible masses, the one that would make M3 move down and the one that would make M3 move up. Okay? So it's going to turn friction around. So the first time, friction will be going down the incline because the system will be moving up the incline. Find the value of that mass. Then redo the whole problem, but have friction going up the incline, which would, because M3 is so small that it's going to get pulled down the incline with the masses. Okay, so these 3 questions for today, and once you have those done, then work on your assignment. But do these first, because you need some more practice with the inclined planes, okay? Thank you muchly. Enjoy your day.